Hey, how's everybody doing today? Happy Tuesday. Hope the midterm went well. I've not had a chance to grade them yet, but it looks like you guys all got them in. So I can spend some time and go over some of the answers if you guys want to that, or we can just jump right into lists and dictionaries. Totally up to you guys. All couple people who are in chat, you guys get to vote. So yeah, let me know if you want to go over the midterm or if you just want to jump right into the next chapter. Let me fire up PyCharm here. Oh, look at that, I even have some of my samples. All right. This is Chapter 8, Lists and Dictionaries. Let's do it in a new window. We can leave them both open. Do you guys have a preference there in chat? Which one we do? I'm open to either. How did you feel it went? Usually I get to watch everyone take it and they get to tell me afterwards if they thought it was good or bad. Hopefully it fit into that 2-hour window without too much trouble. Well, you guys are a quiet bunch. That's okay. That's all right. Mostly good. Okay. All right. You're the first person to talk. You win some bonus points. Sadly, bonus points aren't actually worth anything. But all right. Oh. So hopefully things are stable here. I had just lost power like 20 minutes ago. It flickered on and off a couple times. Stayed off for a good minute or so before it came back. So I was worried. I don't know. They were doing construction around here and putting in a new subdivision behind me. Checking the same values for your functions. Okay, you can give it a shot. You guys want to look at some of them? Do that? Sounds like fun. Let me go to quizzes here. I think I can open this up in Canvas. Let's see if we can work Canvas. So I want to edit the midterm, right? There we go. And we'll take a look at the questions. So the short answer style, you had 14 of them. They were literally, I just imported them from your other quizzes because I didn't want to bother rewriting them, just to be honest. So hopefully those went well and you guys felt good about that. No one has ever asked me about the quizzes. Like if they got something wrong, they never asked what they got wrong. And, occasionally I'll put notes in there. I don't know, usually when we're in person, usually we go over them in person, and we've kind of been missing out on that. So maybe we should go over them in person, but they're questions just from the quizzes, so I think those are going to be okay then, unless you have specific questions. We can jump right to these longer answer style questions. So there's one about primes, there was one about Unicode, and then there was one about just some character checking stuff. So we can look at each of these if you guys want. Oh, sorry, that's a little bit small, isn't it? I think I can zoom it in maybe. Wow, that's not super helpful there. Like it keeps it in that tiny box. All right. How about sum? This is difference of primes and non-primes through n. The sum of all prime numbers 1 through n minus all non-prime numbers 1 through n. Okay. And again, I gave you the little is prime function here, and I've got that here in a midterm review. I just copied it into here. So I added my is prime. This was just a copy paste. I even cited my source. What does it mean by locked? I'm not sure. What does it mean, like you couldn't go back into them to view them? All right, so we wanted, which one is it here? Maybe I didn't actually have that one in here. I thought I did. All right, we'll just add it in. That's fine. So this is the difference. Oh, I'm sorry. Yeah, I thought I had them open, but maybe it's better that they were locked. So I mean, you've seen the question before, but yeah, shoot me a note, or I can take a look at those after class and work on unlocking them so you can see them. All right, so we want the difference between primes and non-prime numbers through n. All right, so we're going to have the, I don't know, a sum or something, starts off at 0. Right, and for number in range, number, I don't know, so n in range, yeah, I hate n, but that's okay. Let me zoom that in for you here. Range number, and we want to range +1. So this is something I'm going to be looking for sure. That n should be inclusive based on this definition, right? Numbers through n, so I think that means including n. If you want to debate that and I take a point off, let me know. But it's probably like 1 point off out of the 5 if you didn't include n. So when we range, we need plus n, and we probably want to start at 1, right? I mean, starting at 0 is not going to hurt anything, but you know, that's okay. It'll return false, and subtracting 0 won't do anything. And we just say here, so we check if n or is prime of n, then we take our sum plus equals n, else sum minus equals n. Right? So we add it if it's prime, n, and we subtract it if it's not prime. And then we return the sum. Does that make sense for this one? Right, you're just looping through every number, taking advantage of that range. You could use a while loop if you wanted, right? You could do that too. Nothing wrong with that. But range is pretty handy and built in. Okay, this is sum of primes in a prime index. In prime indexes, given a list. This one was a little bit different, so given some list, we're going to return the sum of all prime numbers in the list if their index in the list is also a prime number. This is like checking a double thing here. This one was just a little bit longer. Given some list. So we need the index number here. So we're going to do a range. Again, we have a sum starts off at 0. And for index in range, length of the sum list, we're going to go through and we're going to check both. Issue checking the index of the list when the numbers were the same. So all we really care about is the index here and then the actual value at that index. So we're going to say if is prime index, right, and is prime sum list at index. Then our sum goes up by the value at that index. And then we're done, we return something. So there's no else in this case, it's just an if. I mean, you could have an if inside of an if, you could do nested, or we could do the logical operator here and them together. I like this. It's effectively the same thing. Okay, so primes in prime indexes, so if the index value itself was prime, it would go. Right, and then the last one is sum of values in prime indexes returns a value of all prime indexes in the list. So it's just if the index was prime, right, is the only thing we care about in this case. So we don't need to see if the number is also prime. So we can essentially copy paste this, and we just care if it's a prime index for this one. Right? That makes sense for those 3 different prime questions. But again, just slightly little different variations. Make sure you guys had different questions was the goal there. And of course, all of you answered the academic integrity question at the beginning, so we shouldn't have had any issues. But are we okay with these ones? Okay. This one here. So then some Unicode-based questions. We're going to do bad encryption, either where you subtract its index position, or a bad encryption where you add its index position. And then you just had to reverse it the other way around. So a quick one direction or the other. So, and this was given some string. So let's take a look at bad encryption. Actually, I think I even have that here, don't I? There, I added it at the end. So bad encryption. So given some string, we need the index value right out of that string. So we're going to range through the length of that string, and then our result list, we just append the ordinal value of that plus the index value or minus the index value, right, depending on which question you had, the plus or the minus version. And then to reverse it, it was given a list instead of a string. We need to build a string and return that string. So for index and range, the length of that list. we're going to take the character value of that value minus the index. So we need to do this one first before you turn it into a character, right? So take the value minus the index because you're adding the index previously. To reverse it, and just add that character to the result string. So again, it was either a minus and then a plus here, or a plus here and then a minus here, just depending on which question you got. All right, and then the last one here was just dealing with characters. Check if all letters are in a string, with the letters to check for and the string to check. That returns true if all of the letters in letter to check are present in the string to check. Okay, so just two different variations. Let's see, did I even have that one? Oh, that was count vowels. Okay, so we'll add those ones in. So we can grab those ones here. I'm going to define, it's a little bit long there, but that's okay. So what we want to do is we want to check this string to see if each letter is in here. So we're going to iterate through this. We're going to say for letter in letters to check for. And if the letter is not in the string to check, return false. Capital F false. If we get through that entire loop and we ever return false, we can return true. Because they must have all been in there if we didn't return false. Okay, and the other one is just a different variety of that. So we're ensuring none of the letters are present. So we do the exact same thing, but it's backwards now. So we're going to define ensure all the letters are not present. And for letter to check and letters to check for, if the letter is in string to check, we return false, because we did find it. If we haven't returned false by the time this loop is done, we're going to return true. Okay, how's that feel? Those ones make sense? Oh, uh-oh. It says my bit rate tanked. Inspector. Let's see what's going on. I might have lost you guys. Yep, we are unstable. Oh, crap. Give it a second, see if it comes back. What's my Wi-Fi doing? Yeah, it's on the 2.4 gigahertz band. That should be okay. Maybe it's just my internet. Give it a minute. Excuse me. Oh, it looks like it might be coming back now. Let's see. Still not back to 30 frames per second. All right, sorry about that. I'll commit all this stuff to GitHub. One more new line? Some number of new lines? There we go. Okay, sorry about that. CIS 1501, there we go. Term. Oh, and I started with a new project, so let me ignore all those ones for a minute. So I'm going to do a selective commit and just commit that one. And push, and then I'll go add all of these ones here for our chapter 8 started, and I'll commit all that, just so it's there. All right, it's thinking real hard about it. Excuse me. I'm a little loopy today on the cold medicine. I've not been able to kick this cold for quite a few days now, which is unfortunate. So aside from the midterm, and if you turned anything in last night, everything else should be up to date in Canvas. So do let me know if you have any questions about your grades there. Or if you have specific questions about any other, the midterm questions or any of the quiz questions. I'm happy to look at those too. Okay, so I'll close down this midterm project and we'll work on the Chapter 8 lists project. Okay, I think we're back in stable. That's good. So we know already that lists are container types, right, where the order matters. And we can iterate through them over the start and the end. You can get individual values out by index, right? So if I have my list, I don't know, we'll just put some numbers in here. 1, 1, 2, 3, 5, 8, 13, on and on and on or so, right? It hates all my extra spacing. I like the extra spacing, but PyCharm does not. So I can say my list at index, and pick a number here. Index 4 will be the 5th item, because this is index 0. 1, 2, 3, 4. Sorry, that should give me the 5, right? If I want to print that one. Right, that's nothing new and special there. We've done this before. But what you can also do, like how we can slice strings by giving it a range of indexes, we can slice lists as well. Right, we can make this makes a copy of it. It's not the original. So once you slice it, right, that's how we can pass a sliced list, right, to different functions. We've been able to do that before. You can add two lists together. You can delete items if you want. There's this cool syntax for deleting a particular item out. So we can delete my list at index, I don't know, let's remove the, how about the 3? So let's index 4. And let's print the list again. Right, removes an item at that position. Oh, that means, did I say 5? I'm trying to remember what I said here. So we can do that sort of thing. It's all good list stuff. You can modify lists, right? They're mutable, unlike our tuples, which are immutable. Other cool things, we got lots of methods. If you want to put something at a particular value, right, we can say mylist.insert, and insert takes two things. It takes an index position, so let's put something at index 0, which is the front, and how about the number 0? So this is index position, comma value. And then we'll print my list again. So it'll add a 0 to the beginning of our Fibonacci sequence, which I think is technically correct. And I don't want to delete. We don't want to mess that one up. Yeah, I think the 0 is technically the first item. I don't know. It's been a little while. I thought it was a 1, but and then there's no previous 2, so maybe it's 0, 1 is just how it starts. All you math people can tell me how it actually goes, and I'll trust that you know the math better than I do. Other ways to remove stuff from lists. We can take the mylist and we can say .remove. Remember, remove will remove a value, but it removes the first value it finds. So if I remove a 1, it doesn't remove all 1s, it just removes the first one that it finds. Okay, so it took out one of the 1s. Okay, you can also pop a particular value. So pop by default will remove the last thing. Or you can also give pop an index value. So this is more preferred pop to this delete syntax. Let me go and insert here after we remove that one. We'll put it back in at index 1. We'll put a 1. So pop is more preferred. It's more idiomatic, right? It's, with the dot notation instead of this weird delete notation. Other cool things we can do. We can take a list and we can sort it. Let's just get a bunch of random values here, actually. That'll be more fun. So let's do import random. And then, for value in range, how about we do, let's do 20 different values. We'll take, here's a new list. We'll take new list. And we'll append random.randint, I don't know, how about 1 to 100? So we'll put 100 values in, and then we'll print new list, and we'll see we've got 20 different random values here, and then we can sort it. We can call mylist.sort. So sort will modify the list and sort it in place. Nope, I sorted my list. I meant to sort the new list. Wonder why those didn't look any different. Let's try that again. Excuse me. Yeah, there we go. That looks much more sorted. Right, so sort's a pretty handy little feature for lists. If you wanted, you could also reverse it. So we'll print it, and then we'll do the new list reverse. So it'll be in reverse sorted order. Oops, I did debug instead of run. I just want run. Runs faster. There we go. So now it's in reverse sorted order. Those are pretty cool. Remember, you can get the count of values. You can get the index of a particular value in a list. Those ones are fun list operations. When we iterate over lists, remember if we do the for value in list, we're getting copies, so we can't actually modify it. We want to use the index value if you want to modify it. You can modify things by index. Yeah, that one we can do. So another handy shortcut, if you want both the value and the index and you don't like typing it, maybe we could say for index in range, length of new list. Right, I don't know, we're going to do some silly math things. So we'll print the index plus the new list at index. I don't know, it's like one of those silly midterm questions, right? We could do this sort of thing. There's also a little shortcut for that. We could say for index and value in, and you call enumerate. Enumerate new list. And enumerate will give you both those things, the index and the value. So then we print index and plus value. And just keeps you from having to type this a second time. So I'm not a big fan of it because I don't mind accessing the list directly. But we should get the exact same thing twice, right? 97. Oops, maybe I should print just a blank line in there in between. We can make sure it's the same. Where's our gap? There it is. So it starts at 89, right? 89, 90, 83, 89, 90, 83, on and on and on, right? Okay with that so far? So enumerate's nice, it's handy. We've done min, we've done max, we've done sum. There's also an all and an any that I don't find particularly useful. So all will tell you if all values are not 0, and any will tell you if any value is not 0. Not super interesting to me, but I'm sure you can find fun uses for it. So those are in there. Other things to do with lists, yeah, that's fine. You can put a list inside of a list, right? We can have a two-dimensional list. I think that's new, right? We haven't done two-dimensional lists, have we? This is my list of lists equals a list. And for, we'll call it row in range 5, list of lists dot append another list. And then, I don't know, we'll have a number 0. So I'll take my list of lists at row dot append, because it's another list, the number, and I'll take number plus equals 1. That's for item in range 5. There we go. So we have a list, and what that contains is more lists. So it's going to look a little funny here, but now we're going to have a list of lists here. Let's see if we can print that off. And I can print a list of lists. So we should get the numbers 0 to 24, right? Here, right? So the first item, 1 through 4, the next item, the next item, the next item, the next item. So that looks a little funny, right? I mean, it's kind of hard to follow, but you can see it's a list, and each item inside of it is a list, right? So it's still one thing, one list, but it's a list of lists, and each list has a bunch of values. So we're sort of cheating here with that one object idea, right? So we'll call this a two-dimensional list. So a lot of times we want to visualize it differently. We'll want to say for row in list of lists lists, we can print the row. So this is a more common visualization. Let me print just another space here. So if we have a list of lists, usually you can imagine it like this, right? This little two-dimensional, here's my rows and here's my columns. Right? First row, second row, third row, fourth row, fifth row, or index 0, index 1, index 2, index 3, index 4. Each one of those then has a particular value that I can get at. So I could say if I wanted, I don't know, throw out a number between 0 and 24, and we'll go print that particular value out. A list of lists. So just tell me one of the values and we'll go find it. We'll get it out of our list. I think I'm going to need some more coffee. Okay, it's 16. So 16 is at row 0, row 1, row 2, row 3. So it's at row 3. So if I just print out that, I'm going to get that entire row. Right? I get that last row with the 16. So then I need which index is it in this row. So that's index 0, index 1. So I'm going to say index at, so list of lists at 3 at 1, or row 3 column 1, if you like to think of it that way. So row 3, we're 0 based, so 0, 1, 2, 3, 3, column 1. So this is column 0, this is column 1. So that ought to get me the 16 out. So with two-dimensional lists, you give it the row and the column location. Okay. And if we wanted to iterate through it, we could say for index in length list of lists lists. And you know, I'm not a fan of index here anymore because that's not meaningful. It's actually the row index. So I'm going to say for column index in range of the length of, in range of length. And now I don't want to do list of lists again. I want to do lists of lists at the row index, because that's how many items are in the particular row, right here. And then I can print my list of lists at row index, at column index. Right, and if I wanted to, I could change that ending character to, I don't know, we'll just space separate them for now. And when that's done, then I'll print a new line. So this way we're going to get rid of these little braces here. Well, maybe we want to end with a comma. I don't know, maybe we don't need commas. So this ought to print it a little bit prettier, and we lose the braces now. So now I just get each item space separated, right? Because I've changed that ending character. Otherwise, it'll all be on their own line. So you get at something by row index and column index in a two-dimensional list. So we can range through the whole thing pretty quickly. But again, you want to know it's row index and column index. Now you don't have to use indexes either. If you wanted, you could say for row in range, or I'm sorry, for row in list of lists, and then now, but now the problem is it's not column, because it's really item, for item in row. I mean, so column's kind of a misnomer there, because the column is like saying, hey, this is the column number, rather than this is a particular item within that row. We could print item, change the ending character to a space, and then when that's all done, we'll just print a new line again, right? So this will duplicate the same thing above. Right? Doing that same duplication. Exact same result. So just different ways of iterating over two-dimensional lists here. Does that make a little bit of sense? It's going to take some practice, and we'll do lots of practice in lab. Yeah, list slicing, you can do the same thing with a stride if you wanted. Those are all fine. One thing you don't want to do when you're iterating over a list is modify it. So if we're saying for item in I don't know what we call that. That was the new list. I think that was the list of random numbers. If we wanted to say remove odd values or something, if item mod 2 equals 1, take new list, remove the item. This is going to cause all sorts of weird stuff to happen here. So let's print new list. New list. We'll take a look at it. We'll see if we can modify it, and we'll print it after the fact. So it should remove all odd values, right? So 95 gets removed, but it didn't remove the 89. It removed the 79, kept the 72, removed the 71, good, kept 64, 60, didn't remove 47. That one's still there. Oh, it's 47's a duplicate. It removed one 47. Left the 46s, the 44, got rid of the 35, kept the 34, got rid of the 29. So you see it's doing weird things. So what's happening is when we're iterating for item in new list, we're iterating over the list as we're going, and what happens is it remembers the index. So it says, okay, so essentially we're getting the item at index 0. Okay? Item at index 0, and then we called remove, so everything shifts down as we go. But the index value doesn't change. So after we did index 0 and we removed 89, it now moves to index 1. Well, when we removed 95, 89 became the new index 0, and we moved to look at index 1, which was the new 79. So looping over a list like this is always going to cause trouble if you're trying to modify it. So what you want to do is you want to loop over a copy. So slice the list. Then, so that we were iterating over a copy, not the original. Now we see all of the odds are gone, because the index values are the same here, right, as this one. And again, we want to use remove. Don't use pop at index, because index values are going to change as you remove stuff out. So do be careful, right? So removing items, always iterate over a copy. Otherwise, you're going to get some really strange results. All right, and then there's this list comprehension thing, which is really fun. Python developers love using these because they're a short, simple syntax. I still get confused by them, and I do them often enough, and like every time I try and use it, I have to go look it up. It's a little confusing. So we're going to say odds. Okay, let's actually let me make a copy of that list. So new list. Original list equals new list. Copy. Original. I don't know if that's spelled right. And for fun, let's print the original list. Make sure we didn't screw anything up there because we want a copy of it. Yes. Okay, so we have the original copy. Okay, we're good so far. So now what we wanted to do, if we just wanted odds, we can say it equals. And now we give it the list syntax here, but inside of the list notation, this list syntax, the square braces, we give it an expression. Right? And it's actually the original here, which is weird. So we're going to say, oh man, this syntax is always funny. So we're going to say we want the number for number in the original list if number mod 1 equals true. And this is crazy. This is like crazy looking syntax. So we're essentially taking a loop and we're putting it into a single line. So I can say print odds. So it says for every number in the original list. So this is like the for list here. Here's an if expression, and actually the if expressions are optional. Like you don't need that, but otherwise it's sort of silly to just have number. I guess you could do like number plus 1, or you could do something here. So this doesn't have to just be number. You could do an expression here like number plus 1. That's perfectly fine, but for our purposes it doesn't really work for us. Were you modifying a list in the midterm question there? Sorry, I missed your question, Sammy. So this should get us all the odd numbers in that list. Uh-oh. If number mod 1... Oh, equals true. Sorry, equals 1. Not equals true. That's silly. Nope. All right, still screwed it up. Let's see. What do we want here? If... Let's see if I can put this in. Force some parentheses here. Nope, nothing. Print odds. Why are we not getting our odd numbers? For number. In numbers. If number mod 1 equals 1. Why are we not getting any? The original list. We have our original list. Trying to make odds. That is weird. Let's try evens just for fun. See what's going on here. Let's try odds and evens. Evens. Something. I'm not doing something right. What's not happening? Well, yeah, that's not right. In the original list, if number mod 1. Oh, you guys. A number divided by 1 here, there will never be a remainder. This is supposed to be a 2. The cold medicine is really getting to me here. When you mod 2 and you have a remainder, then it's an odd number. When you mod 2 and there's no remainder, it's an even number. Okay, all right, that looks much better. Right, so these are all the odds and these are all the evens. Yes, okay. Okay. Sorry, the cold medicine is making me loopy. Loopy. Yeah, a lot of those midterm questions could be a little bit more complicated if depending on how you went about it. All right, one other fun thing you can do. Remember .sort will sort the list here. Where is that one here? So this will modify the list. There's also another method you can call, which is called sorted given some list. And sorted will create a new list from this one. Now I know they're already sorted, but they're sorted in descending order. So maybe we'll call this sorted odds. So sorted gives you a new list without modifying the original. Sorted creates a new list. So that's the big distinction. So if you want a sorted list and you want to modify it, use .sort. If you want a new list and not to modify the original, you use sorted. Just ways of going about it here. You can also really cool, you can give it a way of sorting. If you give it the key argument, that's probably trickier than anything we're going to do. So we're going to skip past that, but just know you can pass it a key to sort on. Their example, you use like a lowercase letter, which is nice. So instead of sorting by uppercase and lowercase, it puts them all together. The command line arguments is cool. You can read all about that later. We're not going to do it in PyCharm or anything. All right, additional practices. All right, and then we've got to dictionaries. So why don't we call it here? We can save dictionaries for Thursday. And I'm still feeling a little loopy here, so I'll take some of this extra time and work on grading your midterms for you guys. And what else do we have going on here? What else is going on? I believe we've got something coming up due as well. If I can get this thing to load, maybe. There we go. Project 1 is due before class on Thursday. So on Thursday we'll cover the solution to Project 1, and then we'll cover dictionaries from Chapter 8. I feel okay? And I don't think... I didn't put a quiz out there for strings, did I? I should really go check. I'm sorry, guys. I'm just feeling a little loopy. Because we're in Chapter 8 now. Yeah, there was no Chapter 7 quiz because we just had the midterm instead. So unless you guys want another quiz, I'll just skip Chapter 7 quiz. You can pretend it didn't happen. We'll call that good. And then we'll do a Chapter 8 quiz after we finish up the chapter. Okay? All right, cool. That's actually all I got for you guys. So finish up project 1. Let me know if you have any questions about that. Is that hopefully going well for you guys? Maybe? Let's see if I can find it here. Project 1, and I want to edit this one. Edit. No, more options. There we go. That's probably the right button. The one way I click on it and it shows me all the submissions, and I don't want to do that. Cool, you got most of it done. Awesome. There it goes. This is our little hangman game, right? Using functions. So specifically needs to have these functions as we're doing it here. I know there's hangman solutions out there. What I want you to do is build one that uses functions. Yeah, if you got problems, let me know. Just shoot me a message on Discord and we can go from there. All right, if not, I'll see you guys on Thursday. Take care.